Last time we checked some commands for managing archives, how to create an archive, how to extract an archive, and also how to create a zipped archive. For example, this one is a zipped archive. Also, this one is another zipped archive, but with another option, with another compression algorithm. Today, let's see how to use the command rsync. So this sync means synchronize or synchronization. It is used to synchronize two directories. And this R is it can be interpreted both as remote and also recursive because it does both of them. Recursive synchronization, subdirectories and their content and so on, but also it can synchronize a directory, a local directory with a remote directory. So it has a lot of options, but to use it normally we just need a couple of options, not all of them. For example, we have this directory testdir here that we created last time to test the archives, the commands about archives. Now I want to synchronize this directory to another directory which is a local one, and I can do it like this: rsync testdir. This is the directory, the target directory where it will be synchronized, and I am going to use also the options A. This A means archive. It will preserve the permissions and the ownership, and this I can also add this V. V is for verbose. Verbose, it is going to print one line for each file that it is, for each action that it is doing. And so at the end it also shows these two summary lines: send this many bytes, received, and so on. Now let's check what it did. So we have this directory foo here, and it actually has synchronized it inside the directory foo. So it has made a copy of testdir inside the directory foo. Why does it happen? So because there is one way to write the name of the directory without the end, the slash at the end, and another way with this slash. And without slash, the name of the directory means the directory itself for rsync. And if I append this slash, testdir with a slash, it means the content of the directory. So in the first in the command that I used above, I did not use any slash, so it means synchronize this directory to this one, and so it makes a copy of this directory inside this one. But if I use this slash, it means synchronize the content of this directory to this directory. So let me delete this one and try again. So Ctrl C, cancel. I am removing this directory foo with the command remove. Now let me try rsync again. Ctrl R. So I am recalling a previous command and I will modify it. I am appending this slash at the end of the name of the directory. And now if I look inside this directory, I see that the content of the source directory has been synchronized or has been placed inside the target directory. I can synchronize also with the remote server that we used to SSH to log in last time. For example, SSH and I get a shell inside this server. And this works because we have created this configuration file. So when I say SSH server 1, then it is going to SSH to the user account Dashamir to this server, server1.fs.al, using this port and using this identity file or this private key. And the private key is here inside this directory. So that's why it works. So I can just say SSH server 1 and I don't have to specify any details. Now how can I use this with rsync? I can say, for example, rsync. Again, these options A and B. Source directory is testdir. And the destination directory is server1.foo. And let me synchronize the content of this directory. So instead of when I specify the target, I can say server name, semicolon, and then the target directory. And it will synchronize this local directory to this remote directory, to this directory on the remote server. So let me try it. Maybe I don't have rsync on the destination server because it says rsync command not found. So rsync has to be present on the local account and also on the remote server. So let me install it quickly. So it is not installed. I can install it. apt install rsync. Now it is present. I log out from the server and I will try the command again. And now I see that it is transferring some files. If I list the content on the remote server, the content of the directory, I see this one, foo. That should be a directory. But let me the command 3 is not present on the remote server. Let me try to install it as well. Or anyway, I can check it. Using the command ls. So I'm running this command on the remote server, ls long listing directory foo, list directory foo. I have a mistake. There is a mistake on the name of the server. So it has transferred all these directories, directory 001, directory 002, and so on, all of them. Now let me try the same command again, the same rsync command again. So I tried this before, it transferred the content of the directory. Now I will try this command again and see what happens. Now this time it is not showing any file transfers, because it is saying here sending incremental file list. So it makes a list of the local files and sends only the modifications to the files that have been modified to the remote server. But no file has been modified so far, so nothing to be synchronized. So this is efficient. If we want to synchronize a local directory with a remote directory, we want to send only the files that have been modified since the last time that we synchronized. So it does the synchronization efficiently. Let me try to modify a local file. For example, dir 001 file z. For example, I will use the command touch. The command touch just changes the modification time of this file, but it counts as a modification. So this file has been modified. Now I run the synchronization command again, and we see that it is transferring only the file that was modified. But what happens if I delete this file instead of modifying? I delete the file dir1001 file z. So let me remove it and run the synchronization command again. Sending incremental file list. It knows that there is a modification inside this directory, but actually it does not remove the remote files. It only synchronizes the existing files or the files that are missing. But if one file was removed in the local directory, it is not removed on the remote directory. We can check this one. So this file is still present on the remote directory. But what if we want to remove the remote files as well? In this case, we have to use another option with the command rsync. So besides these options -a and -v, we should also use this option delete. And in this case, this option delete means that if a file was deleted in the local directory, delete it also on the remote directory. Or if a file is missing on the local directory, but it is present on the remote directory, then remove it from the remote directory. So that this is the total synchronization. So we completely synchronize the local directory with the remote directory. So the remote directory becomes an exact copy of the local directory. Not only copy the modified files, but also remove the files that are that have been removed locally. And we can check that the file is not present on the remote directory. So on server 1, we are trying to list this file, but it says no such file or directory. So it has been removed on the remote directory. Now let's see how to create user accounts in Linux. In order to create user accounts, I will access the remote server SSH server 1, and I can use the command user add to add a user account. Let me try the help command first. Help. user add command not found. This happens because this command user add can be executed only by the super user, by the root, by the user root, and normal users cannot even access it in this case. So I have to become a super user, and I become a super user with the command sudo su. This means switch user, and without the name of the user, it will switch to the user root, to the super user. And this means do as a super user. Now it is asking the password, my password, the password of account Dashamir, which is my email address, as you know. Now the prompt of the super user is a little bit different. Usually it is with this hash, but it depends. It is not always like this. And now I can try the command user add again. And these are the options of this command. Let me try user add. The name of the user, the new user. For example, test1, the name of the new user. So add a user with this username. And now I'm going to use also some options like -m and -s. The option -m is this one here, create the user's home directory. So the command will also create a home directory for this user. And the option S is this one here, shell. So it is telling what shell should be used for when this user logs in. And it is going to use /bin/bash or bin bash as the shell for this user. I'm pressing enter. And how do I check whether the user has been added or not? User home directories usually are in this directory, /home. And we see here home directories for all the users that are present, but there is also this home directory for the new user that I just created. I'm leaving the root account, and if I check, for example, home test1 cannot open directory, permission denied, because only this user has permissions on this directory, not this user. But I can run this command as a super user with the command sudo. So I'm recalling the previous command. And sudo, it worked, but the directory is empty actually. So if I run a command with the command sudo, then this command will be executed as a super user. And this time it did not, the command sudo this time did not ask me for a password. When I used it before, sudo su, it asked me for the password of user Dashamir. But this time it did not ask. Why? Because it remembers for some time that I've authenticated. So if I write the command sudo and it is asking me for a password, then next time, or for example for 5 minutes, it is going to remember that I typed the password and is not going to ask me again. let us check also the file password, where in this file are listed the user accounts. So let me try nano. So there are some accounts for system services. These are system accounts, but there are also some user accounts here. And this is the account that I created, and I see that Andreas has already created his account. So Andrea is already following, and there is also this file /etc/group, and this is a list of the groups in this system. And usually when a user account is created, also a default group is created for this user account. And there is a group for the user test1 here that I created, and another one for the user that Andreas created. Control X. And if I look again at the file password, here it is supposed, for example, to be my password, but because this file is visible, is readable by everyone, the password is not stored in this file, but it is stored in another file, which is called shadow. It says permission denied, so normal users cannot access this file because it contains the passwords for each account. So I will try with sudo. This time I can access it, but see, this is my password, but it is actually the hash of my password. It is like a kind of encrypted password. From this string I cannot find out what is the real password. But the system can verify. If I give the password to the system will convert the password to this hash and can verify that the password is correct or not. Now, let me see the ownership of this file. The ownership, it belongs to the user Dashamir and the group Dashamir that created, this is the user that created this file. If I want to change the ownership of this file, for example, to make it root, I can use the command change ownership. Change ownership of the file food.txt, and the owner will be root and the group root, the same. But if the owner and the group is the same, I can leave out the group. But it says operation not permitted. So only the super user can change the ownership of a file from one user to another. So what we do, we run the command with sudo in front. So I'm pressing Ctrl A and sudo. And let me check again the ownership, and now it has changed the ownership to the user root. That is the super user. Now let's see some things about environment and environment variables. We can list environment variables with the command printf. Printf, and I will pass the output of this command to the command less Let's not found. Okay. And these are the environment variables that are present in my shell, in my current shell. For example, this home is the home directory. It contains the location of my home directory. And this user is the current user. When I press who am I, for example, it is giving me the content of this environment variable. And path is another important variable that contains the directories where the shell is looking for a program or for a command. For example, when I type ls, it is looking first into this directory to find the program ls. If it is not in this directory, then it is going to look into this directory and so on until it finds it. Press Q. And I can see the content of variables with echo and dollar, for example, user or dollar home or dollar path. Now this is the shell expansion. So it starts with a dollar, and the shell is interpreting this as an environment variable and is replacing this with the value of the variable, and it is giving to echo the value of this variable, and echo is just showing it, is displaying it on the screen. Another environment variable is pw1 or let me check again. Pw no. It is ps1. And this ps1, this variable actually contains the value of the prompt. So it is the prompt that is being displayed by the shell, but it also contains some special characters that modify the color. For example, this /u means the current user, the name of the user. And then there is this @ sign here, this @ sign, and then this /h is the name of the server, the host name. And these are codes. This is the code for the green color, for example, for the green color that is used here. And so this is why it is displayed with colors. Now, the environment variables are created at the time that we log in to the shell. So we give the username, the password, we log into the shell. At this time, the shell is loading some configuration files that define these environment variables. So what are these configuration files? These files are, for example, /etc profile, if it exists, but there is no /etc profile here, I see. Or if we look at the current directory, we see this .bash rc. This is one of the files that is loaded when we log in. And also this .profile is another one. So here, for example, it is defining the variable path, and here it is modifying it, appending or prepending another value. Here we see some other variables that are defined. For example, his size. His size is the size of the history of the commands. So when we type commands, these are appended to a list of these are remembered by the system. And when I press, for example, the arrow up, I can recall the previous commands. How can I recall them? Because the system is keeping these commands into a history file. And this variable, his size, is the size of this list, 1000. So it can save up to 1000 previous commands. And here, for example, we see the variable of the prompt being defined. So this is a colored version, and this is a version without colors. Now let's say that we want to modify the variable his size. So right now it has the value 1000. Let's say that we want to make it 2000. Then we can change the variable his size . But if I log out from the shell and log in again, then I will see that it will be again 1000. For example, exit and log in again and check again, and now it is 1000. Why? Because at the time that I make login, the file .bashrc is loaded by the shell, and in this file it is defined with the value 1000. So if we want to make this change permanent, so if I want to make this change permanent, I have to edit or to append it to the file .bashrc. So let me copy it. And I can either modify it here, or I can go at the end of the file and append it. And let me check it. I will do exit and log in again and check the value of this variable. Now it is the modified value. Now let's play a little bit with the variable ps1. So this is the current value of the prompt, which is showing this prompt. If I change it, you see that the value of the prompt is changed immediately. And let me change it again. So this slash dollar, I'm using this slash to escape the dollar. Otherwise, it will be replaced by the shell. The shell will try to interpret it. So this is just a dollar and then an empty space here. And this is the prompt that I get, a dollar and empty space. Now I will change the prompt again, ps1 slash a empty space slash h empty space slash dollar and an empty space, another empty space. Now this slash a, as you can understand, is the current time, hours and minutes, I guess. Yes, it is UTC. The time zone is universal time. So it is this time right now. And this slash h is the username, the host name. So the name of the host, the name of the server that I am running right now, I am accessing. And let me modify it another time. And here I'm using slash u @sign slash h. So this slash u is the user and slash h is the host name, and also a dollar sign and an empty space. Now how do I revert the prompt to the original value, to the value that it had before I tried to make modifications? I can just log out and log in again. Exit and then log in again, SSH server 1, and the normal prompt is back again. Why? Because I did not save this modification. So if I wanted to make the modification of the prompt permanent, for example here, if I wanted to make this modification of the prompt permanent, then I should add this line to .bashrc, to the file to this file. But because I changed it at the prompt but not appended to this configuration file, then it is just temporary modification, and next time that I log in I get the version of the prompt that is defined here. I am exiting from the server, and we will see some more examples with the archive command tar. For example, the command tar, we are going to use this this test dir directory. So it has a structure like this. Now I can archive files by giving the absolute path of this directory. For example, this is print working directory, and then slash test dir. So this is the absolute path of the directory test dir, of the directory test dir. Now I can archive this directory tar create archive, and the file will be testdir2.tar. But notice that the command tar is removing this leading slash, this one, from the path of the directories and files that are being included in the archive. And if I look at the content, if I look at the content of this archive file that I just created, table, verbose, file, and then testdir2.tar, and let me also pipe it through less. So we see that the leading slash here is missing. The command tar has removed it from the path. And now if I try to extract the content of this archive, tar extract, archive file is testdir2.tar, and change to directory foo. So this option will go first to the directory foo, and then will extract the archive, the content of the archive. But let me first look what is inside this directory. It should be empty. So I am commenting this command. It is not empty, so I am going to empty it to make it empty. Now it is an empty directory, and Ctrl A, I am deleting this this character, this commenting character that make this a comment, and I will execute this command. And now let me look what is inside the directory foo. So it has created, it has extracted all the files with the path, because each file is stored into the archive, including the path, home, user1, testdir, and so on. But the path does not include the leading slash, which makes it an absolute path. And this makes sense because if I extract this archive file, and all the files are extracted with absolute path, then they can possibly override some existing files in the current system. But this way they are extracted with a relative path to a relative directory. Now, when we use the command tar x, usually we extract all the files in the archive. But if we want, we can extract only some of the files, not all the files. For example, let me empty this directory foo and try another example. So this is an empty directory, and the archive file is in the directory above, in the parent directory, testdir.tar. So I'm going to extract some files from this archive. But before extracting, let me list some of them. Tar, this option -t is table, and then this f, this is the option -f, which shows that this is the archive file. and then I will say so I am listing, but only this the files that match this name, and only this file will be listed. And if I extract, I can use the same command to extract, but I will replace t with x for extract. And we see that it has extracted only this file from the archive, the file that matches this path. If we did not specify this path, then all the files in the archive would extract all the files in the archive. And we can also use wildcards with this pattern. So instead of just specifying the path for one file, we can specify that we can tell it extract all the files that match this pattern. Or we can use shell expansions. For example, the same command, but I will extract from the directory 2 the files A, B, C. And this is a shell expansion. Shell will expand this into three file names. And we see that it has extracted also these three files. Now, we can also use this option wildcard in order to use wildcards. Wildcards, and then specify the wildcard here, like this. Dir star, and then file D. So this is the wildcard, this star, which tells match all the files with this pattern. So it will include 001, 002, 003, and so on, and it will extract the file D from each of the directories. So this is what it did. It extracted all the files named file D inside each directory. And we can combine the command tar with other commands. For example, we can use the command find. Let me go one directory above. And I will remove this test directory to clean up. And now I can use the command find into this directory. This is the directory where we are where we are searching. all the files that match this name. And it is listing all these files that match this name, file A. All the files in this directory. But now we can extend this find command with the operation exec, which is going to execute the command, the given command, which is the command tar, this option R, and then this option F. So these are a little bit advanced examples, but let's do them anyway. They are not so complex. Now, this F is telling the command tar that this is the name of the archive, testdir3.tar. And this R is actually, it means replace, but actually it does append. If a file does not exist in the archive, it is going to append it. And this exec is going to execute the command, the given command, to each file that is found by the command find. So it will execute it for the first file, for example, and will append it to the archive directory, and then it will find the next file and execute this file, this command again, and it will append the next file to the archive, and so on. For each file that it is finding, it is going to append it to the given archive. And this is a syntax specific to the command find. So if we use exec and a command, then this means the file that was found. So this is actually a placeholder for the name of the file that was found. And it also needs something to end the command. Maybe a semicolon here, or maybe this plus. Let me try it. Let me execute it. And now let me see the content of this file archive. And pass it to the command less. So it actually contains all the files named file A in each directory. So this command worked well. So it did the job as expected. Now I can execute the same command again as before, but now I can look for files named file B. And because this is appending, replacing or appending, then it will append to the archive all these files. Let us look at the content of the directory. So we have all the files named file A, and then appended to them are these files named file B. Now I will write a complex command, and I will try to explain it little by little. So first we are running the find command, find in the directory testdir. The files that are named file A. So this is simple. It will look for all the files that have this name. So let me run this command. It will find all the files. Now I am passing the output from this command to the command tar. So I am piping it, the output of the command to the command tar create. But now the file will be this minus. Instead of the name of the file, of the archive file, I am using this minus, which means which means that the output will be sent to the standard output. And then this minus t, and then minus again, and then we will pipe the output to the command gzip, and then redirect it to testdir.tgz. testdir.tgz. So let me try to explain it again. So the command tar will create an archive with this option create. But what will be included in the archive? This option minus t usually takes a file, and this file has the names of all the files that should be included in the archive, one per line. But because instead of a file we are giving this minus, then it is reading the data from the standard input. The standard input is coming from the pipe, which is the output from this command. So this minus here actually means all the names of this file. So this is what will be included in the archive. And then this option minus f specifies the name of the archive file. For example, testdir.tar. But I'm not giving a file name here, but I'm giving this minus. And this minus is telling the command tar to send the output to the standard output. And standard output usually is the screen, the display. But I'm piping it. I'm piping the standard output to another command, which is the command gzip. Gzip makes compression, compresses the data. It is taking the input from the standard input, and it is sending the output to the standard output. Standard output is the screen, the display, the terminal. But I'm redirecting the standard output to this file. So actually the data will be stored into this file, into this archive file. So let me press enter. And it has created this archive file. Now let me look at the content of this archive file. Tar, look at the table or the content, and I'm using this option Z because it is zipped with this program, and the option F. Let me also add the option V for verbose. Testdir.tgz, and I'm piping it to less. So actually it has included all the files with this name in the archive. So let me call the previous command again. Instead of piping to the command gzip, we can use the option Z of the command tar. So I can remove this pipe and use the command Z, the option Z. This option Z does the same job as this gzip. And also I can combine these options, and also this one here to make it nicer, and it actually does the same job. And if I look at the content of this archive again, it is all the files named file A. And instead of using this option Z to compress, we can use the option J. And let's change the extension of the resulting file, tbz, because this option J is using another command like this one. It is called bzip2, and it is using another compression algorithm, and let's look at the content of this file, of this rsync file that we created, tbz. But now instead of z, we will use the option zj to uncompress it. So instead of z, we are using the option j to uncompress. And again, it is the same. Now, if I look at the size of this file, and look at the size of the other file, we see that this file is smaller. So this compression command or this compression algorithm does a better job. Okay, we can stop here today, and we will